Morning from my side. Our first talk in this room is from Monica Sarbu. She's from Elastic and she's talking about monitoring the infrastructure with Elasticbeats.
Today I'll talk about how to monitor your infrastructure using the Elasticbeats. A bit about myself. So my name is Monica Sarbu and I'm working for Elastic, the company behind Elasticsearch, Kibana and Logstash. And I'm team lead in the build team. So if you want to monitor your servers, usually the first thing you do, you want to get the logs from your servers. For example, if you have an Apache server, then you will be interested in getting the Apache logs in order to monitor your Apache server. But then you decide that you also want to monitor the processes that are running on your servers. And you are interested, for example, in memory usage and CPU usage for all the processes. But then you want also to monitor the health of your services by interrogating periodically that servers and fetch metrics from it. Sorry, wrong button. But then if this information are not enough for you, then probably you also want to see the interaction between your servers and see the messages that are exchanged between your servers. Then you also maybe want to see the HTTP transactions, for example, the MySQL transactions that are exchanged between your servers. In the world of microservices and containers, you don't have to monitor a single server. So you have a bunch of servers, 100 servers, 1,000 servers, and even more. Then you probably want to have a central point where to store and collect all this kind of information in order to be able to search across them and also do analytics on them. And this point is Elasticsearch. And you don't have to worry that you have to scale your infrastructure because Elasticsearch was built from the first day to be a scalable system. So it grows with your data, and because it's a scalable and distributed search engine. In this talk, I will concentrate in how to collect and ship different kinds of operational data and ship them to Elasticsearch using Beats. Beats is part of the Elastic Stack. Elastic Stack is a suite of open source projects, Beats and Logstash on the engine side, Elasticsearch, which is a storage engine, and you can do analytics on your data, and Kibana that can be used, it's a UI that can be used for visualizing your data. The Beats family consists of FileBeat that is used for collecting your log files, Metricbeat, which is for interrogating periodically services and fetches metrics from them. Then it's Packetbeat for listening to network data, and WinLogBeat for collecting Windows event logs. And you can create your own beat based on the Beats platform. A proof is that there are already created over 30 community beats. Let's start with FileBeat. So FileBeat is like running the tail -f on all your servers, but instead in printing the result on the screen, it ships the result over the network to Elasticsearch. And it comes with some extra powers. For example, it had support for multi-line. Think of these Java exceptions that are on multiple lines, and usually want to combine them to see the exception in only one line. JSON logs, think of these applications that have support for structure logging and filtering. For example, you want to store only a subset of your log lines. For example, you want to store only the error messages. FileBeat sends the raw log lines as they are, so without parsing them. Here is an example. If you want to parse your log lines, then you will have to write your own grok patterns. And there are two ways how you can write your grok patterns. One option is to use the ingest node, which is a plugin for Elasticsearch. And the second option is to use Logstash. in the second case, you basically need that file bit to send the data through Logstash, not directly to Elasticsearch. Here is an example of a grok pattern. For example, in this message, we can identify that the first part is the client, then we have the method, the get method, and then we have the URL, then the number of bytes, and the duration of the get transaction. After applying the grok pattern, you will be able to have the message, the log message parsed. Here is an example how the message will look like in Elasticsearch. An important feature that FileBit has is that its capability of handling back pressure. Why back pressure is important? Because FileBit is a lightweight shipper that can send the log lines at the maximum speed. And you have to take care not to overload Logstash. So that's why it's important for FileBit to be able to slow down when it's needed. So the way it works is that FileBit reads a bunch of log lines, then sends them to Logstash, then waits for ACK from Logstash, and only after it receives the ACK from Logstash, then it marks the log lines as acknowledged. Then writes the offset until when the log lines are read into a registry file on disk. And in order to make sure that the offset is written on disk, that it performs a fsync. And only after that, it reads the second bunch of log lines. So what this means is that FileBit is able to adapt its speed depending on how fast the next stage can process the data. And if, for example, the next stage is down, then FileBit waits and doesn't read any log lines. So this means that doesn't buffer the log lines on disk, doesn't allocate any memory, so doesn't lose any log lines. Another important feature that FileBit has is that it's able to guarantee that each log line is sent at least once. Why I mean at least once and not exactly once? Well, because it was theoretically proven that this is impossible to send a message exactly once. As a consequence, over a lossy connection, this is a consequence of the two Byzantine general problem. So let's take an example to show that it's really impossible to guarantee that the log message is sent exactly once. And let's take an example, FileBit and Logstash. So FileBit sends a bunch of log lines to Logstash, and in case Logstash is down or it becomes unavailable for some reasons, then FileBit is not able to know if Logstash processed or not the data. So there are two options here. One option is to drop the log lines, and in this case, FileBit can guarantee that each log line was sent at most once, which is something that we don't want, right? And the second option is to resend the log lines to a different Logstash instance. But in this case, we might have duplicates, especially in the case that the first Logstash already processed the log lines. And in order to solve the duplicates, we are planning to do the following thing: to assign a unique ID for each log line and try to deduplicate the log lines at the indexing time in Elasticsearch. This way, we kind of simulate that each log line is sent exactly once. Let's see how we can use FileBit to collect the log lines. This is a very delicate topic, especially because, as you can see, there are quite many options on how to get the logs from your containers. And all of these options, they have issues, at least at the moment. So I would like to go and show you a few possibilities on how to collect logs. So first option will be to use the Gelt driver together with Logstash. But this solution has a biggest disadvantage that is UDP-based, so you cannot guarantee that the log lines are delivered. And also, there is no congestion control. Another option is to use the JSON driver from Docker together with FileBit. This is a really simple solution to set up because JSON driver is a default driver in Docker. And another disadvantage is that it's easy to get the container metadata like the name of the container or the label of the container. Another thing is that the Docker logs command works in this case. The disadvantage is that some people think that by enabling the JSON driver, it slows down a bit the Docker container. Another option is to use a syslog driver together with a syslog server together with FileBit. The advantage of this solution is that you know the path where the log files are stored, and also comes with rotating your files. You get this for free. So the disadvantage is that you need to manage another server, the syslog server. The metadata from the container are serialized, so you have to deserialize them. And in case of multi-line, it's very difficult to get that because the data from different containers is mixed. Another option is to use the journald driver together with FileBit. The advantage, similar like with JSON driver, you get support for container metadata, and also Docker logs works. But the disadvantage is that FileBit doesn't have yet support for journald, but there is a journald bit from the community that has that. Another option is to use share volume together with FileBit. So what this means is that you mount a directory from your host into the container, and then you instruct the application to write the logs into that share directory. This solution is very easy to set up, especially when your application supports rotating the log files. The disadvantage is that it's difficult to pass a container metadata this way. So in conclusion, all the solutions that have FileBit involved have support for at least once delivery guarantee, and also is able to handle back pressure. And the other solutions like using a Gelt driver together with Logstash or FreeND driver together with Logstash comes with no guarantees. And here it's up, as you see, there are quite many solutions, right? There are advantages and disadvantages for each. Is this your call to decide which one fits better for your infrastructure? Now I would like to talk about Metricbeat. Metricbeat is a new beat that we just released a couple of weeks ago with 5.0 release. And the way Metricbeat works is like interrogates periodically external services, fetches metrics from them, and then push them to Elasticsearch. And we have support for a few services like Apache, NGINX, MongoDB, MySQL, PostgreSQL, Redis, Apache, Zookeeper. And you can also add support for a different service by creating a module in Metricbeat. Metricbeat comes with a system module. that fetches system statistics from your servers, like CPU usage, memory usage, disk I/O, file system load, network per CPU cores information, per process information. Now let's see how you can use Metricbeat to collect the metrics from your containers. And actually, there are two options how you can do that. Only two options. One option is by querying the Docker API. And with this, you get information about the CPU and memory usage, Docker container information, network information, in and out bytes, drop packets, disk I/O information like reads versus writes, and also you get the status of your containers, like how many containers are stopped, how many containers are running, things like this. There is a Docker module in Metricbeat that gets container information by querying the Docker API. Docker module is not yet released, but it's already in the master branch in GitHub, so if you want to check it out. The advantage is that it's very easy to use. You don't have to set up anything, and it has access to container names and labels, which is very important. Another option is to get container information by reading the C groups data directly from /proc. And the advantage is that you are able to get this information no matter what container technology you are using, not only Docker. Another advantage is that you don't have to query the Docker API, which sometimes might have security concerns. But the disadvantage of this solution is that you are not able to get the container name and the container labels. You can get only the container IDs. So if you are enabling the C groups option in the configuration file of Metricbeat, then automatically the process information will be enhanced with C group information. No matter what option you are using to collect the container information, you might want to run Metricbeat in a container on your host in order to monitor all the containers that are running on that host. The objection that I get when I'm presenting Metricbeat is that Elasticsearch is not meant to be a time series database. Because people think of Elasticsearch as a search engine that is very good for text search, but is not so efficient for storing numbers. And actually, this is not really true. Elasticsearch and Logstash and Lucene, the project behind Elasticsearch, improved quite a lot in storing the numbers recently. And this actually got even better with Elasticsearch 5.0 with the introduction of a new storage engine that is based on BKD trees. So let's see what BKD trees are. So initially they were introduced because they have support for multiple dimensions. Think of GeoIP points where you have two dimensions, one longitude and one latitude. But this proved to be very efficient also for one dimension value. And these are numbers, right? So with BKD trees, it's faster to index, faster to query, more disk efficient, and more memory efficient. Another disadvantage that Elasticsearch had before 5.0 was that it was not able to compress float values. And they were stored on 4 bytes. There are quite many compression algorithms, and think of this Gorilla paper from Facebook that describes the compression algorithms. But unfortunately, they cannot be used because of the Lucene way of storing the values. So with Elasticsearch 5.0, as a workaround, there were two new flow types introduced. One of them is half flows, which is always stored on 2 bytes. And this has good precision for small numbers, but the precision degrades with the bigger number it is. The second type is scale floats, which is the idea is to store a float numbers as an integer using a scaling factor. So what this means is, for example, if you have a scaling factor of 100, you multiply 100 by your float value, and the result you store it as integer in Elasticsearch. And when you query Elasticsearch, you divide the value by 100 and you get result back. And this is useful, for example, if you store percentages. Think of, for example, the CPU usage, right? So why Elasticsearch is good for time series, for storing time series? So because it comes with horizontal scalability, it has a mature support for clustering, it comes with flexible aggregations, including moving averages and hot winters that you use for anomaly detection. You can use a single storage system to store logs and metrics. Comes with specialized UIs for visualizing the data, especially metrics, like Timeline, Grafana. And it comes with a great ecosystem in the sense that it comes with alerts, alerting, and reporting, and things like this. Now let's have a look to Packetbeat, which is for getting the net that is listening to the network traffic. So the way Packetbeat works is like installed as an agent on your server, is listening to the network traffic that is exchanged between your servers, then decodes upper layer protocols, correlates the request to the response into transactions, and sends them to Elasticsearch. And from the decoders, we can note HTTP, MongoDB, MySQL, PostgreSQL, DNS, Redis, Memcache, Cassandra, and so on. And here you can add support for another protocol by creating a module in Packetbeat. If you have an unknown traffic, meaning that there is no decoder for that protocol, or that your traffic is encrypted, you can still see a few details about the traffic that is exchanged between your servers. And this can be done using flows. So with flows, you can have a few information like the number of packets, the number of bytes, retransmissions, and so on. Packetbeat can also be used to monitor the traffic exchange between your containers. All you have to do is to install Packetbeat in a container on your host, and you'll be able to monitor the traffic that is flowing between all the other containers that are installed on that host. Let me show you now a quick demo. One second. Is it big enough? Okay, so now I'd like to show you how you can monitor your containers using the Elastic Stack. And for this demo, I have a virtual machine with Ubuntu installed on my MacBook, and where I installed FileBeat, Packetbeat, and Metricbeat. It's very easy to install them. So you just need to go to the web interface, to the web page of Elastic, download the package that you want. In my case, it was a Debian package, and you install it, and then you have it. So that's why I'm skipping this step. And now let's start a container with where Redis is installed. And as you can see here, I'm passing some labels in order to see how the containers labels can be monitored with the bits. So now I'm starting the container, and now let's open the configuration file or FileBeat to show you how you configure FileBeat in order to get the logs from the Redis container. So here you need to configure a prospector and with the path from where to fetch the logs. As you guys know, if you, by default, the container has JSON driver enabled, so it writes the log lines in a JSON format under this path. So basically, it monitors this path. And now if I start FileBeat, then FileBeat will send all the log lines to Elasticsearch and store them in a special index in FileBeat. It's a FileBeat index. Let me show you. So if we go in the index patterns, I have already created the FileBeat index, right? And now let's go to the discovery page. Select the FileBeat index, and we will be able to see all the log lines from that container Redis that I just created. And as you can see, let's go to one. We can see here basically one log line that the Redis container prints when it starts. And as I said, the logs are written in a JSON format, so we'll be able to see that here in a JSON format. So it has the log, the stream, and the time. In addition, FileBeat also exports the offset of the log line and from where basically the path and the name of the log file. Okay, now let's see how we can get the metrics from our Redis container, and for that, let me show you the configuration file of Metricbeat. And here you can configure multiple modules. For example, we have here configured the system modules in order to get system statistics like CPU usage, load, file system, and so on. Another module that I enabled is a Redis module that interrogates the Redis servers and gets a few information from the Redis server. And here you can specify what kind of information you want to get from the Redis server and how often to query the Redis servers. And of course, the host of the Redis server. And another module that I enable is the Docker module. So in order to get information about our Redis container, we had to enable that. And here, as you see, we can, I hope you can see because of the colors, And here you can specify what kind of information you are interested from your Docker container. Of course, you can specify how often to fetch the information from your container, the host, and also optionally the socket that is used. Okay, now if we are starting Metricbeat, Metricbeat will send the metrics information to a special index pattern in Metricbeat. So let's select a Metricbeat index. And as you can see here, I get all kinds of information. So let's drill down and, for example, check the system statistics. So, for example, here I get information about the 5 system statistics, how much available, how many mount points, and things like this, right? Also, we can get information about the processes, for example, and we get one event for each process. Yeah, like the state of the process, the PID of the process, the memory that is used by the process, and things like this, right? And now let me show you information about Redis. And you can see here I get information from the Redis servers, like, yeah, things like, yeah, as you can see, kind of a lot of information, but let's go to some easy ones like, yeah, for example, the operating system, the server version, things like this, right? So uptime. Okay. And now I would like to show you also the Docker information, and for that we filter to the Docker module, and as you can see we get quite a lot of information. For example, we get information about our Docker container. As you can see here, we get the labels that I passed when starting the Redis container. And also I get the socket name and memory usage, things like this, right? And what is interesting is that each metric has a round trip time that is counted automatically. Now let's drill a bit down and show you a few information about the Docker container, like how many containers are running, how many are stopped, how many are paused, and things like this, right? And the name, the ID of the container, the name of the container. Yeah, the name of the container is not here. You can also get statistics about your containers. Like, as you can see here, the container ID, when the container was created just a few minutes ago. The uptime of the containers, it's 7 minutes. And things like this, right? Now let's see some details about the CPU usage of the container. As you can see, we have the CPU usage in percentage, and what's important here is the container name, right? And which is because usually you get the container ID. But it's very difficult to match which one you are interested in. So that's why, in my opinion, I think it's nice to have the name of the container. So in this setup, as you noticed, we are getting the information from the containers using the Docker API, because I didn't set anything up. As you see, it's out of the box. And that's why in this solution, we can get, with this solution, we can get the name of the container. Okay, now let's see how we can get the traffic that is exchanged between our containers. And for that, we need to change the configuration file of Packetbeat. And the default, basically the most important option that you need to configure in Packetbeat is the interface on which to listen for the traffic. And in our case, it's any. And also for each type of protocol, you can specify the port where to listen for the traffic. So in our case, we don't have to change anything. We can use the default configuration. So let me generate some Redis traffic by generating a set command in Redis. And now if we are starting Packetbeat, we'll be able to, Packetbeat will send all the Redis transactions to Elasticsearch, and we will be able to see them. So let me first select the Packetbeat index. Let me generate again. It's there, but just to be the top one. Yeah, as you can see here, the query is here. It's the query, the Redis query that I already started, and you can also see a few details about that query. What is also important here, as I mentioned in the presentation, you can also get if you are not able to decode your traffic, or you have encrypted traffic, you can see details, a few basic details about your traffic by using flows. And let me filter for those. As you can see here, I have a few details like the number of bytes and the number of packets exchanged between the source and the destination, together with the IP of each for each. So the number of bytes and packets exchanged between the source and the destination, and the other way around, right? Okay, I think that's it. If you have before going to if you have questions, I would like to mention that in the last day of the conference, there is a hackathon about the Elasticbeat, where a colleague of mine will present on how you can create your own beat, or how you can contribute to open source community by creating a module in one of our beats. So yeah, thank you very much for your attention. Now, if you have questions, feel free to ask me.
When talking about FileBeat, the biggest...
Sorry.
Hi. Talking about FileBeat, the biggest issue is always handling the file rotation. What is FileBeat doing about it?
So, just to clarify your question, so the application needs to take care of rotating the log files. But in case the files are rotating, FileBeat is able to detect that.
So FileBeat is continually tracking the log until it stops, and then it takes the other one? Or?
Yeah.
Okay.
Yes.
Do you have any performance analysis on the number of metrics that can be inserted per second, and like in comparison to other time series databases, as well as like queries that can be performed?
That's a really good question. Unfortunately, I don't have a formal answer for that. We didn't do any official benchmarking on that. We only have some internal ones that, I don't know them by heart. But to answer your question roughly, it's there are some comparisons between Elasticsearch and InfluxDB. And of course, Elasticsearch cannot really compete with other systems that are specialized in metrics. But the difference is not big. And you have to think that Elasticsearch is a generic system that gives you the chance to use a single system to collect all kinds of data, not only metrics, but also logs. Compared to other metrics vendors or specialized vendors that are specialized in metrics, right, that can do only metrics. So our goal is to offer a system that is generic enough. And we are trying to, already with all the new improvement that we did for 5.0, we are going towards competing with the others competitors for metrics. That's why I presented quite in depth in my presentation that Elasticsearch is an option for a time series.
Hello. Quick question. You mentioned in case the next stage in FileBeat is down, everything is queued up with FileBeat itself.
Sorry, can you
Okay,
repeat?
let me just repeat. Sorry. In case the next stage with FileBeat is down, you mentioned that FileBeat is just storing the messages by its own. So means the recommendation is there's no need of an additional queuing mechanism like Redis or Kafka? No
yes,
need.
that's true. So in case the next stage is down, for example, Logstash or Elasticsearch, FileBeat doesn't have where to send the data. So what it does, it doesn't queue or buffer the log lines in additional place, right, on disk. It waits until the next stage comes back again, or if there is another one available, it sends them to the other one.
Good, thanks.
Any more? Here?
Hi. Concerning the beats in general, how do they manage the connections? Do they establish the connection on demand to send off the data, or is it a stale connection?
If it's a,
if it is a stale connection, so if one of the beats, FileBeat or Metricbeat, is supposed to send new data, do they then establish the connection, or do they constantly keep a connection open?
Yeah, so idea is to keep the connection open, just not to open too many connections. Yeah.
And how do they notice if you? So what is your recommendation if you have a couple of thousands of beats? How do you scale then on the receiving part?
That's an interesting question. Yeah, I'm not sure I can give you the right answer for that. So we invested quite a lot of time in improving the connection between the beats in Logstash and also with Elasticsearch. And of course, we deal with all these things that you said, but I don't know to give you the technical details about this.
Okay. Thanks.
But if you want to know more about it and you are here for the hackathon, you can ask the guy that he implemented this part. And he can give you, I'm sure, a lot more information about that.
Hey, a couple of questions. First, to figure out whether I've understood this correctly, will the FileBeat be the officially suggested way to ingest log data in Elasticsearch in the future?
It depends on your infrastructure. So the idea, if you are asking between what's better, FileBit or Logstash, then the answer is that they have different use case, right? FileBit is for getting the logs from the edges, and Logstash is more concentrated on the edge, on the server side. And soon, Logstash will also have support for queuing. So it will be, its place won't be at the edge point. I hope this answers your question.
Okay, and I really like the first question about the log rotation, and you said that it's supported, but there's a lots of different scenarios how applications handle rotation of the log files. So some of them overwrite the previous file. Some of them write in different log file with a different file name every day or every hour. Then there's some applications that update the timestamp on the file. Have you delved into this nightmare?
Yes, we did that. Fortunately, we spend a lot of time trying to figure out what's the best solution for tackling all these problems. And we have quite a bit of configuration options in order to have support for one case or another. If you are interested, you can check the documentation. I think in our documentation, it's described in details. All these configuration options that you can use to solve one option or another option. But that's true. It's it was a bit of a hassle.
Thank you. I'll check that definitely. Thanks.
Welcome. And if you have questions, feel free to send us a message on our forum at discuss.elastic.co. And also, if you find bugs, feel free to post them on GitHub, on our GitHub repository. Anyone else? More questions? Yeah?
Hi, I have one general question regarding Bits products. Are you going to release something, some alerting model like alert Bits or something like this for anomaly detection or something?
Okay, so I'm not sure I totally understand your question. The question is, do you refer to implement a bit that is handling security cases?
No,
or do you want to refer to have support for alerting? Okay, yes. So for that, it's so Elastic is coming. It has already Watcher, which is a closed source solution for alerting, and you can use that together with.
But unfortunately, it doesn't support like anomaly detection.
Yeah, for anomaly detection, I don't know if you guys know, but Elastic recently acquired Prelert, and we are working in integrating a solution for that into Elasticsearch. So, it's coming up soon.
Thank you.
We are working on that.
Okay, so we are done. No more questions. Thank you very much.
Thank you very much for listening.
And